are there specific causal modeling tools or resources that you highly recommend to listeners?
Yeah, this is a great question. People often ask me for book recommendations and stuff like that. So probably the one that I'm most excited about is my friend Robert Ness has a new book coming out on Manning, and I've only gotten to read like a little bit of a preview. I don't think the entire book is done yet, but that's a book that I recommend checking out. I think that like causal inference and causal modeling is less about like a particular set of tools or methodologies than it is like a holistic way of thinking about solving problems. Is kind of like we use a number of different tools to do causal models, but you can do a causal model with linear regression, or with just like measuring two means and subtracting them is a valid causal inference technique. So it really is like there's a diverse set of tools that can be applied, but it's kind of like the way you frame the problem and set up the problem that's the important part. And obviously, I'd be remiss if I didn't mention the kind of DAGs and Pearl's work, and thinking about building these graphs of causality is a really powerful tool for trying to frame the models that you're ultimately going to have to estimate. But also experimentation is a big aspect of causal modeling. The best way to create a causal estimate is to actually run an experiment and do some randomization. And that's a whole other set of methodologies that's like what I would call design-based data science, where instead of analyzing data that's already been produced by someone else, you're designing the data that can answer the question that you need to answer. And so that's another methodology that I recommend people become very familiar with. So
Yeah.
it's just like it's like 10 different things and nothing, I guess.
That latter methodology, where you're really being thoughtful about how you design your experiments, that seems to be Professor Hill's preferred way about thinking about causal problems. We talked about that a lot in her episode, in episode number 607. In contrast, Emre, Dr. Kitcheman, in episode 613, it seems like he thinks a lot about the DAG, so the directed acyclic graphs that allow us to explicitly identify how we think different variables are related to each other, and then allow the data to bear out in that DAG. So two different kinds of approaches there for listeners to dig into in those separate episodes. It's great to hear your take on it, Sean, and just kind of the general overview that there's lots of different approaches out there, including taking two means and subtracting them.
Right. If it was an experiment, that's a great approach. Yeah, I think it's like it's fun to reflect on this. Like everyone wants to be told there's one tool that they should learn, and I think ultimately it's right tool for the job, and it's very generic advice. But it's why understanding the fundamentals is so much more important than understanding like how to use a particular tool.
And so one tool that a lot of people who aren't maybe deeply involved in causality might have thought would be the answer to all of their causal problems was profit. So we mentioned that a few minutes ago. So before Lyft, you worked at Facebook and helped develop their famous automatic time series forecasting package, Profit. And more recently, last year on Twitter, you addressed some of the criticism that Profit received for automating a process that is often not one size fits all. And so here's a quote. You said, "The lesson here is important and underrated. Models and packages are just tools. We attribute magical powers to them as if their creators have somehow anticipated all the idiosyncrasies of your particular problem. It's unlikely that those creators have anticipated all those idiosyncrasies, and there's no substitute for evaluation." And that kind of point is something that Professor Hill brought up a lot in episode 607 as well, which is that I'm going to butcher the quote here, but the concept that she was describing is that that there are no true causal tools. There are only packages for doing causal modeling where you as a human need to be comfortable with the assumptions that are being made. So it sounds like that's the same kind of point that you're making there.
Yeah, I think we always have to interpret any answer or number that a model or anything else spits out within the context of how it was created. And diagnostics are the way that we do that. We sort of like pay close attention to does it produce answers that make sense in situations where I know the answer, or where it could have been known what the answer was, and then you build confidence through doing that over time. I think when people just kind of like blindly apply methodologies and hope that it's going to work, that's exactly when we tend to fail. And it kind of highlights the problem is that it's much more fun and interesting, and easy to fit a model than it is to assess whether it's good or not. And diagnostics and model assessment and model validation isn't very fun, but it's probably far more important. And I often tell younger data scientists that like probably that you should start with writing down how you're going to evaluate a model before you even think about fitting it. And it's something that it's not the fun part, so we tend to kind of like, it's like eating your vegetables. we tend to eat dessert first in data science a lot of the time.
Right. Yeah, we come into this job for the fun, not the data cleaning.
No.
um, I want cool models. So, do you have any thoughts on how the data science community can disrupt this tendency that you're describing for conflating tools, especially maybe seeing a single tool as a one size fits all solution to their specific solution? How can we?
Yeah.
Yeah.
One of the things I've really been enjoying seeing are these kind of like packages or projects that make accessible many different methodologies simultaneously. For benchmarking or comparison on either on the same problem or on a set of problems. And academics kind of sometimes produce these review papers or comparison type papers. I think that this is a very valuable thing for us to be doing, is saying like, hey, we have a variety of tools that have all been developed for the same problems. Let's just like compare them in some fair environment and try to do some benchmarking. So the people who build like benchmarking or tool comparison tools are doing great service to everybody, because they make it easier to facilitate learning about the properties of these algorithms, in across a wide variety of potential use cases. But then generalizing that to your specific application is also going to be a leap even from there. So like maybe something works well on 9 out of 10 data sets, but your data set is the 10th one. And so you still can't trust other people to have done the work for you under any circumstances if you really care about the quality of the result. And I think that things that help us with diagnostics and visualization of diagnostics are probably even the most important tools. So those are what I think we should be focusing on as a community, and kind of like help rewarding people for finding problems and for fixing bugs and for helping to assess things, rather than anybody can develop a new methodology. I think that's relatively easy. It's just like whether it's good or not is a really hard question to answer, and it takes a long time. So people that help us come to some consensus about what works and what doesn't are probably doing the most important work.